All right, so our next lesson is solving two-step equations. Our guiding question, how are two-step equations solved? Now, solving two-step equations pretty much comes down to one of two methods. One way is to work backwards to isolate the variable. Isolate means to get by itself. The other method is to multiply by the denominator. We will have examples that use both methods. Now, when we were learning about evaluating expressions, so expressions is this one over here, we used order of operations. Now, whether you use PEMDAS or GEMS or whatever, you have to simplify. You work down this way. So we have groupings, then we simplify our exponents, then multiplication and division from left to right, and then addition and subtraction again from left to right. Now, when we are solving equations, we are actually going to start with addition and subtraction, then multiplication and division. And in the next example, I'll show you what happens if you don't follow the process. So here's our first example. We have the two-step equation 3x subtract 4 is equal to 5. Now in another video I talked about how coming up with an estimate first or using some mental math is a fine idea. So in this situation we have 3 is being multiplied by something, by a number. Then we are subtracting 4 and the result is going to be 5. We need to figure out what that number is going to be. Well, let's just try a couple. So 3 times 1 is equal to 3. If I then subtracted 4, I'm going to equal negative 1. That's not going to work. We need it to equal 5. Let's try the next one. Let's try 3 times 2. So 3 times 2 is equal to 6. If I then subtract 4, this time I'll equal 2. All right? Got closer to 5, but we're still not there. Next we'll try 3 times 3, which is equal to 9. I subtract 4, and that will equal 5. Wonderful. So now I know that I'm going to be multiplying 3 times 3. So therefore my variable x is equal to 3. So now we know our answer. All right? Let's use that to make sure that we know how to solve this two-step equation. So first I'm going to solve it incorrectly. Now, in order of operations, we would first multiply, then we would subtract. So if we followed that same process here, so the opposite of multiplication is division. We divide by 3. The 3's are going to cancel. 3 divided by 3 is 1. That will leave us with x. Subtract 4 over here equals, let's see, 5 divided by 3 is, let's see here, oops, let me fix that really quick. 5 divided by 3 is equal to 1 and 2 thirds. Okay? Then the next thing I would do, I have to subtract 4. The opposite is a positive. So I'm going to add 4 to both sides. Negative 4 and positive 4 equals 0. That leaves me with x. Over here, 1 and 2 thirds plus 4 is equal to 5 and 2 thirds. Alright. Well, I wanted to equal 3 and it equaled 5 and 2 thirds. So obviously this process didn't work. So we've reset our problem. Remember, we have an estimate, or we know our answer is going to equal 3. Now I'm going to show you the correct way to solve it. So the opposite of the order of operations means we deal with addition and subtraction first. Well, you can see that 4 is being subtracted from the 3x. The opposite of the the opposite of a negative 4 is a positive 4. So we'll add 4 to both sides using the addition property of equality. A negative 4 and a positive 4 are going to cancel out to equal 0. That will leave 3x over here. And then 5 plus 4 is equal to 9. My next step, 3 and x are being multiplied. The opposite, or the inverse, is division. So I'm going to divide by 3 on both sides. 3 divided by 3 is equal to 1. In the other video we learned that you don't have to write the 1. 1 times x is equal to x. Over on this side, 9 divided by 3 is equal to 3. And there's our solution. Let's do a really quick check, even though we sort of did this already. So we substitute 3 times 3 minus 4 equals 5. 3 times 3 is 9 minus 4 equals 5. 5 equals 5. And we're good. All right, in our next example, we've got 23 is equal to negative 9b plus 5. Now, an estimate for this one can be a little tricky because of that negative. But remember, since 23 is positive, then that negative 9 has to be multiplied by a value that will get us into the positive. So b probably has to equal a negative. All right? So we'll just leave that as our estimate. So draw our line. Now in our last example, we proved that the opposite of order of operations is what we're going to use to solve two-step equations. So now we've got negative 9 and b being multiplied, and the 5 is being added. All right, so we're going to deal with that 5 first. Opposite of a positive is a negative, so we're going to subtract 5 from both sides. 5 minus 5 is 0. 23 subtract 5 is equal to 18. So we've got negative 9b is equal to 18. Now, negative 9 and b are being multiplied. The opposite is division. So we're going to use our fraction bar to show the division. Negative 9 divided by negative 9 is equal to 1. That will leave us with b. Over here, we have a positive divided by a negative will equal a negative. So there's our negative that we needed. And 18 divided by 9 is equal to 2. So we should have our solution there. But let's check it and make sure. So we have 23 equals negative 9 times negative 2 plus 5. Let's make sure this is going to work. So 23 equals, see, a negative times a negative is a positive. 9 times 2 is equal to 18 plus 5. 23 equals, that's the 18 plus 5 is equal to 23. We're good. All right, example 3. So this time our two-step equation is slightly different. You can see that our variable w is being divided by 2. Then that value is being subtracted by 4 to equal a negative 12. So again, we've got negatives in there which make things kind of tricky as far as coming up with an estimate. Just thinking here, if w divided by 2 has to then subtract 4 to equal a negative, I'm kind of guessing that w has to equal a negative. We'll find out. So, draw our line. Now, the first step is still going to be the same as what we've been doing. W and 2 are being divided. 4 is being subtracted. We're going to deal with addition and subtraction first, so we're going to do the opposite of our negative 4. We're going to add 4. Negative 4 and positive 4 is 0. That's going to leave us with w over 2 equals, let's see here, so negative 12 and positive 4. Now some of you are going to be tempted to write negative 16. Let's prove why it's not negative 16. So we have 4 positives, 1, 2, 3, 4. We have 12 negatives, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We can make, let's see, 1, 2, 3, 4, 0 pairs. That looks like 1, 2, 3, 4, 5, 6, 7, 8. So 8 left over and they're negative. So w over 2 divided by, w over 2 equals negative 8. Now w and 2 are being divided. The opposite is multiplication, so we're going to multiply by 2 on both sides. Over here, 2 and 2 are going to cancel, leaving you with w. 8 times 2 is equal to 16, and a negative times a positive equals a negative. So there's that negative that we were kind of thinking. Now let's do a quick check and make sure. Let's see if I can do it down here. So check. W is negative 16 divided by 2, subtract 4 equals negative 12. So 16 divided by 2 is equal to 8. That's going to be a negative 8 then, minus 4 is equal to negative 12. That negative 8 plus a negative 4 is equal to negative 12. And I'm out of room, but when you add two negatives together, you keep it negative, add to get a sum, And yep, we've got negative 12 equals negative 12, so our solution is good. All right, our last two-step equation that we're going to solve here is the one that's we're going to use method 2. So we actually have to work with that division first. So let's see if we can come up with an estimate so we can understand this problem. So we have a value n is going to be added by 7, and then that's going to be divided by 3 to equal 22. So I'm kind of thinking that n has to be a little bigger in this case. I have to have a value divided by 3 to equal 22. So something divided by 3 to equal 22. So that has to be a little bit bigger, maybe even in the 60s, something like that. All right. So we're going to estimate that n is somewhere near 60, somewhere around there. All right. So we're going to draw a line. Now, the n and the 7 are being added, but that entire expression is being divided by 3. So this is the one where we're going to actually work with the division first. The opposite of division is multiplication, so we're going to multiply by 3 on both sides. So those 3's are going to cancel. That's going to leave you with n plus 7 over here. 22 times 3, let's see, 66. Okay, so we're at 66. So our next step, so we've got n plus 7. The opposite of a positive is a negative, so we're going to subtract 7 from both sides. The positive and the negative 7 are going to cancel to equal 0. That's going to leave us with n. Let's see, 66 subtract 7, I've got to borrow here, make that a 5. 16 subtract 7 is 9. Bring down the 5, 59. So our estimate of 60 was pretty darn close. Let's do a quick check and make sure. So n plus 7, so we have 59 plus 7 divided by 3. All right, so 59 plus 7 is equal to 66. Divided by 3 is equal to 22. I kind of ran out of room. It's a little messy, but it does in fact work. All right, last example, word problem here. A college student mows lawns during the summer to help pay for tuition. She charges $15 per lawn plus $4.50 if she has to use her own lawnmower. If she mowed 35 times during the summer and used her own mower 23 times, how much money did she make? Wow, what a great problem. All right, so let's start up with our basic problem. So we know that she charges $15 per lawn. Okay, per lawn means that there's going to be multiplication there. If it's one lawn, multiply by 1. 2 lawns, multiply by 2. 3 lawns, etc. So we're going to need a variable there. Now the second part says that she charges an additional $4.50 if she has to use her own lawnmower. And that's going to give us the total amount that she makes. So this is going to be our total over here. So that's kind of our basic equation that we have. Now, we have we have more than that. We have a bunch of variables here. So we have x is going to be the number of times she mows. So number of times she mows. Now we need another variable because sometimes she uses her own lawnmower. So we're going to say, we're going to say L for that one. L for lawnmower. So she uses her own lawnmower a certain number of times. Okay, so that's going to be her own lawnmower. And that L is going to be multiplied by the $4.50. And then once we have all that, we should be able to get the total. So our new equation is going to be 15x plus $4 L equals our total. All right, so now we can actually solve this like we would expressions. We're going to substitute the number of times she mowed, which is 35. So x is going to equal 35. And L will be the number of times she used her own lawnmower, so that's 23, so L equals 23. We're going to substitute these values in here and simplify to find our total. So 15 times 35 plus $4.50 times 23 equals our total T. Now I'm going to do some calculations off to the side using a calculator to simplify that since I don't have a lot of room. So 15 times 35 is equal to 525. $4.50 times 23 is equal to $103.50. That's going to equal my total. If I simplify that, my total will be, let's see here, $628.50. Not bad, not bad. All right, last slide. We're going to answer the guiding question in your notes. Our guiding question, how are two-step equations solved? We've got a sentence starter for you. Two-step equations are solved by, and then you go ahead and finish it up. And then remember, we'll do the assignment for this lesson in class tomorrow.